Hi everyone, this is the part 3 of our topic. In the previous video, we discussed about differentiation rules. Link on the description below. Now, we will discussing about derivatives of trigonometric functions. Derivatives of trigonometric functions. In what follows, we assumed that u equals to g of x and that u prime exists. Note that if u equals to x, then u prime equals to 1. Here is the list of the derivatives of trigonometric functions. First, we have if y equals to sine u, then y prime equals to cosine u dot u prime. In other words, if y equals to sine x, then y prime equals to cosine x. Next, if y equals to cosine u, then y prime equals to negative sine u dot u prime, the same as if y equals to cosine x, then y prime equals to negative sine x. If y equals to tan u, then y prime equals to secant squared u dot u prime, same as if y equals to tan x, then y prime equals to secant squared x. If y equals to cotangent u, then y prime equals to negative cosecant squared u dot u prime, same as if y equals to cotangent x, then y prime equals to negative cosecant squared x. Secant u, then y prime equals to secant u tan u dot u prime, same as if y equals to secant x, then y prime equals to secant x tan x. Lastly, if y equals to cosecant u, then y prime equals to negative cosecant u cotangent u dot u prime, same as if y equals to cosecant x, then y prime equals to negative cosecant x cotangent x. Example number 1. Let y equals to sine 2x. For example number 1, derivative of sine is cosine. 2x there is the u and as well the angle. So derivative of 2x is 2 and the derivative of sine is cosine. Now, y prime equals to cosine 2x multiplied to 2. And the final answer is y prime equals to 2 cosine 2x. Example number 2. Let y equal to secant square root of x. Example number 2. We know that derivative of secant is secant x tan x. In this case, we have secant square root of x tan square root of x multiplied to the derivative of the angle of the u, which is the square root of x. We have 1 over 2 square root of x, and we arrive to the final answer. And the final answer is y prime equals to secant square root of x tangent square root of x all over 2 square root of x. Example number 3. Y equals to cosine 3x tangent 2x. Example number 3. Applying the product rule, we take cosine 3x as our f and tan 2x is as our g. Remembering the product rule, copy the f and derivative of g, which is tan x, with the g, and derivative of f, which is the cosine 3x. We have y prime equals to cosine 3x multiplied to secant squared 2x times 2 plus tangent 2x multiplied to negative sine 3x times 3. Let's distribute and then we arrive to the final answer of y prime equals to 2 cosine 3x secant squared 2x minus 3 tangent 2x sine 3x. For example number 4, we have y equals to 3 secant x minus 10 cotangent x. In this example, we will just differentiate each terms. So for the solution, we have y prime equals to 3 secant x tan x minus 10 multiplied to negative cosecant 2x. And for the final answer, we have y prime equals to 3 secant x tan x plus 10 cosecant 2x. For our last example, we have y equals to sine x all over 1 plus cosine x. Example number 5. In this example, we will applying the quotient rule. So we have y prime equals to quantity 1 plus cosine x times cosine x minus sine x times negative sine x all over 1 plus cosine x squared. Next, we distribute to expand our equation. Y prime equals to cosine x plus cosine squared x plus sine squared x all over 1 plus cosine x squared. Remember your trigonometric identities, particularly your Pythagorean identities. We know that cosine squared x plus sine squared x is simply equals to 1. So we have y prime equals to cosine x plus 1 all over 1 plus cosine x squared. You see, we can cancel some terms here, which is the cosine x plus 1, both in numerator and denominator. At last, we obtain to our final answer, which is y prime equals to 1 all over 1 plus cosine x. Now, let's assess yourself by answering the practice problem for this topic. You can pause the video so you can have an ample of time to solve the problems before it reveals the answer. Good luck! Tricks in solving derivatives of trigonometric function is copy the angle and derivative of the angle for you to solve easily. I would like to thank you for all of you for all your overwhelming support on this channel. Without you, this channel could not reach 100 subscribers. We will keep on improving this channel so that you can learn more. On the next step, we will be going 200 soon, so help me to reach that goal. Thank you. On the next video, we will discussing the inverse trigonometric functions. So stay updated by subscribing and turning on the notification bell so you will be notified for the latest videos. If you like this video, hit the like button. You can comment your suggestion so we can improve this channel. You can share this with your friends or classmates. Bye for now.